I would love to see an example of what constitutes compression on a pile and what constitutes tension.
Okay, good question. So if we have our typical pile installed in the soil, here's our ground level or grade. So a compression load on a typical helical pile would be the load we placed on top. For instance, our building, our deck, whatever we put on top of the pile. When I'm talking about tension loads, I'm talking about uplift, trying to pull the pile out of the ground. So a good example for tension is, for instance, if we have a circus tent, and we have the actual ropes going down to the ground to stabilize the tents. Now, if we had our typical helical pile, this rope would be trying to pull the pile out of the ground. This would be an excellent example, and this would be a 100% tension load. An example of a compression load would be you can imagine a simple deck on the front of your home, and then you have grade level, and then it would be simple, your helical pile, and then your connection point between your deck and your helical pile. Yes?
Could you explain what torque means?
So, you have an automobile? Yes. When you take it to the garage and they put your winter tires on, they have to tighten your nuts on to a specific torque. So they use a specific wrench. It either has a needle that bends or it clicks when you reach that specific torque. Your car is probably 80 foot-pounds of torque before it clicks. So if you can imagine, a helical pile is exactly the same thing if you can imagine a very large torque wrench on the top, where your wheel nuts will probably take 80 foot-pounds of torque. Our piles will take up to 239,000 foot-pounds of torque.
Wow. So it's just about not being too tight or too loose.
It's all about reaching the torque that's required for the compression or tension load, whatever the application is.